Hello everyone, so this is Muhammad Ruhul and today we will discuss about Zelder method for the determination of percentage of nitrogen in a given organic compound. A given organic compound contains how much percentage of nitrogen that we will now calculate by using Zelder method. Okay. So for this apparatus used is, now you can see the apparatus in the diagram is now showing this. So in this apparatus we use organic compound along with first adding sulfuric acid concentrated. So what reaction takes place in this case, let us check once. So first organic compound will be there. So organic compound should contain nitrogen, because if nitrogen will present, then it will give us the percentage of nitrogen. So the organic compound containing nitrogen is treated with concentrated sulfuric acid, as you have seen in the diagram. So when it is treated with concentrated sulfuric acid, then what happens? Here ammonium sulfate will form. Ammonium sulfate will form. Why ammonium sulfate? Sulfate from the here. So nitrogen present in the organic compound. Nitrogen present in the organic compound will convert into the form of ammonium ion. Nitrogen, hydrogen is present. Also hydrogen is present in the organic compound. So nitrogen is first converted to ammonium ion. Then it is treated with alkali. Then ammonium sulfate formed is treated with alkali. When it reacts with alkali, then what may be the product? This will give us sodium sulfate, ammonia and water. Sodium sulfate, ammonia and water. Now Na2, SO4, sodium sulfate. Now NH4, ammonia will evolve. So 2 NH4 are there. So 2 ammonia will be evolved. And 2 OH and 2 H left from here. NH3 is evolved. H is remaining. So H and OH, water. How many water will form? 2. So first organic compound, their nitrogen is converted into ammonium ion. That ammonium ion is treated with alkali and then it is converted to ammonia gas. So this ammonia is formed. So we require ammonia. So if we can know what is the amount of ammonia produced, amount of NH3 produced in the reaction, then we can easily estimate the percentage of nitrogen in the organic compound. So for determination of the amount of ammonia produced, we react the ammonia with sulfuric acid. So when we react the ammonia with sulfuric acid, so this will react. So ammonia is base, sulfuric acid is acid. So acid and base will neutralize each other. So what volume of acid is used that for neutralizing ammonia, that we will use. So what product will be formed? Ammonium sulfate. Product is ammonium sulfate. NS4 2 times, whole twice SO4. Now this sulfuric acid solution is taken as standard. So it is taken in excess quantity. Suppose for neutralizing ammonia, If exact sulfuric acid is used, that is neutralized by ammonia, then our job is done. But it is taken in excess quantity because we don't know how much ammonia is produced. If we know that suppose ammonia production is 5 ml, then we can estimate its amount. So we can take this 5 ml, then this will neutralize completely. If ammonia produced is suppose 5, this will take 5. If it is 10 ml, then we will take it as 10 ml. But the main thing is that we don't know what is the volume of ammonia is produced. This we have to determine. So sulfuric acid is taken in excess quantity. It is taken in excess quantity. Now from excess quantity, some volume is used to neutralize the ammonia. Some volume is used to neutralize the ammonia. Suppose it is taken as 100 ml. Out of 100 ml, some volume will be used to neutralize the ammonia and some volume will be left. Then again the same problem is there. How can we know what volume of sulfuric acid is used for neutralizing the ammonia? So for that, remaining volume of sulfuric acid, here some volume is used to neutralize the ammonia. Remaining volume of sulfuric acid, we want to know how much it. Suppose remaining volume is 60 ml. Then we can say that remaining is 60 ml. Out of 100, 40 ml is used for neutralizing ammonia. So what is the volume left of sulfuric acid we have to determine. So we can say that the volume of sulfuric acid left is determined. First we have to determine this. This is determined by titrating it with standard solution of NaOH. So for determining the remaining part of the sulfuric acid, we will titrate it against sodium hydroxide. So sodium hydroxide is a base. So in titration, so after titrating, we will get the exact amount of sulfuric acid, what is its left. So from sulfuric acid, remaining amount we got. Then from this we get the volume of ammonia. Once we got the volume of ammonia, then problem will be solved. Now, so let us consider the volume of NaOH required for neutralizing sulfuric acid be V1 volume. So let now what reaction we can write? Sulfuric acid, this is remaining sulfuric acid will be titrated against sodium hydroxide. If it is titrated against sodium hydroxide, then what product will be formed? Sodium sulfate and water. Sodium sulfate and water will be the product. Now you can balance 2 times. Okay. 2 times Na2SO4, 2 times of water. So these are the reaction taking place in Gelder method for the estimation of percentage of nitrogen in a given organic compound. So diagram you have seen already at the starting part. Reaction is organic compound containing nitrogen first treated with concentrated sulfuric acid. Then it is converted to ammonium sulfate. Then ammonium sulfate is treated with alkali. Then it is converted to ammonia. we require the volume of ammonia used. Why? From volume, further calculation will be observed. So we want this, how much volume of ammonia is produced. Our main aim is to finding the volume of ammonia. So how we will find the volume of ammonia? So we are treating ammonia with sulfuric acid, that is the acid. Ammonia is a Lewis base, so this will neutralize each other. So what volume of sulfuric acid is used for neutralizing ammonia? We don't know. So it is taken in excess quantity. So if it is taken in excess, so some volume will be used for neutralizing this ammonia and some volume of NaOH, sulfuric acid will be left. The left part of the sulfuric acid is determined with the help of titration against NaOH. Titration means it is also neutralizing part. NaOH will neutralize sulfuric acid. Now, so let us consider the volume of NaOH is used is V1. Suppose. Now calculation part. Let volume of NaOH used. Volume of NaOH used be, suppose V we have taken, having molarity M. So volume of NaOH having molarity M used for neutralizing sulfuric acid. This volume be V1 ml. Suppose V1 we have considered. So if the volume of NaOH for neutralizing sulfuric acid is V1, then what will be the volume of H2SO4? Therefore, volume of H2SO4 will be how much? Volume of H2SO4 will be how much? The volume of H2SO4 used for having molarity M. Volume of H2SO4 having molarity M used for neutralizing sulfuric acid. Neutralizing sulfuric acid will be how much? Now see, 2 moles of NaOH is neutralized by 1 mole of sulfuric acid. So 2 moles of NaOH is neutralized by 1 mole of sulfuric acid. So for 2, 1 is required. So for V, 1 by 2 is required. Suppose for 2 mole of NaOH require 1 mole of sulfuric acid. So 10 ml will require 5. Vml will require V by 2. 2 moles require 1. So 2 ml require 1 ml. So 1 require half. V required V by 2. So sulfuric acid required is V1 by 2 ml. So this is the volume of sulfuric acid used for the neutralizing or titrating NaOH. Now, sulfuric acid, what is the volume? Let V be the volume of sulfuric acid. Volume of sulfuric acid is suppose V. Okay. So from V volume, from V by 2, V1 by 2 is used for neutralizing NaOH. So sulfuric acid, we have taken what is the volume of this V. Out of V, V1 by 2 is used in neutralizing NaOH. Its volume we have considered V. Out of V volume, V1 by 2 is used for neutralizing NaOH. What is the left part of sulfuric acid? Volume of sulfuric acid left will be how much? Therefore, volume of sulfuric acid left is equal to, so it initially was V. Out of V, V1 by 2 is used in neutralizing NaOH. It is taken in excess quantity. Its volume is V, we have considered. So out of V, V1 by 2 is used in neutralizing NaOH. So how much left? So we are just minus. Now, we got the volume of sulfuric acid. What is the volume of sulfuric acid? V minus V1 by 2. Now see, the volume, it is how much? 1 mole, 1 volume. 1 volume of this required 2 volume of ammonia. 1 volume of sulfuric acid required 2 volume of ammonia. So this left volume will neutralize ammonia that we have discussed earlier. Therefore, V minus left which neutralize ammonia. So how much ammonia is used for this purpose? You see, 1 volume of sulfuric acid require 2 volume of ammonia. Therefore, how much it is? This one. So this required 2 times of ammonia. From the equation it is seen that 1 volume of sulfuric acid required 2 volume of ammonia. Therefore, we can see that since 1 volume of sulfuric acid having molarity V, having molarity M, required equal to how much volume of ammonia? 2. So required equal to 2 volume of M molarity ammonia. Okay. So if 1 volume of sulfuric acid required 2, how much sulfuric acid is left? This, which neutralize ammonia. Therefore, V minus V1 by 2, this much volume of sulfuric acid having molarity and will require 2 into this, 1 के लिए 2, for this 2 into V minus V1 by 2 volume of M molarity NS3. Okay. So we finally got the volume of ammonia produced in the reaction of Zelder method. So finally we got the volume of ammonia produced in the Zelder method. Now we will use it for calculating the mass of nitrogen. Mass of nitrogen. How? Now see, so this is completed. Okay. Suppose molarity. What is the formula of molarity? Given mass by molecular mass. Given mass by molecular mass. Molarity. Formula. Given mass of solute by molecular mass of solute into volume of solution in liter. volume of solution in liter. So we can say that if molarity is 1, given mass of ammonia, molar mass of ammonia is 17, volume if we take 1, if volume we will take 1, volume in liter we have considered 1, then what we will get, given mass of ammonia is 17 gram. So from this condition we will say that what, 1 liter of 1 molarity, suppose 1 molarity is also 1 we are taking, suppose if 1 molarity is there, 1 liter volume is there, then mass of ammonia will be how much? 17 gram. 17 gram ammonia, or mass of nitrogen will be how much? In ammonia, what is the mass of nitrogen? 14 gram. Mass of nitrogen is 14 gram. Nitrogen 14, hydrogen 1 into 3. So if we consider these 2 points, then only, so we can say that since 1 liter means what? You say 1 liter or 1000 ml, both are same, and this volume are in ml. So we can say that 1000 ml of 1 molarity, 1000 ml of 1 molarity NH3 contains, this contains is equal to 1000 ml of 1 molarity of NH3 contains 17 gram of ammonia, 17 gram ammonia, or 14 gram nitrogen, both are same. So we are converting volume into gram because we require mass of nitrogen. Why? Because our aim is to find the mass percentage of nitrogen. Now, see. So 14 gram ammonia. So this part we have used here. Therefore, 1 ml of 1 molarity ammonia contains equal to 1 ml of 1 molarity ammonia contains will be how much? Oh, m molarity, this. Okay. So this part. So 1 ml, so this will be 14 by 1000. This much gram of nitrogen. Therefore, how much it is? Volume V minus V1 by 2. V minus V1 by 2 ml of 1 molarity ammonia contains 14 by 1000 into V minus V1 by 2. Oh, sorry. What is the, not this, we require what? Ammonia. So 2 volume of m molarity ammonia means 2 times of this. This is for sulfuric acid. Now we require for ammonia. What is the volume of ammonia? 2 times of V minus V by 2. Therefore this will be how much? 2 times of V minus V by 2. Okay. Into this one we have got. So this is the mass of nitrogen. This much gram. And this m molarity ammonia, so for m molarity multiplying by m. So whatever be the value of molarity, that will be multiplied. Suppose molarity is 0.5, so we will multiply 0.5 and so on. Okay. So 2 times of this ml of 1 molarity ammonia will contain equal to, so ml contain equal to 1 molarity is gone there. Okay. 1 molarity gone that side. So this much ml of ammonia, this much ml of ammonia contains molarity ये जो था goes to this. Okay. So we got the volume of NH3, this much gram NH3. What is this? Given mass of nitrogen. So we got the given mass of nitrogen. This is the mass of nitrogen, not ammonia, nitrogen. This is the mass of nitrogen. Now what we require? Mass percentage of nitrogen. Therefore mass percentage of nitrogen will be how much? By formula, mass of nitrogen by mass of organic compound, mass of organic compound into 100, mass of organic compound into 100. Now give it in the formula. ये formula पे दे दो, क्या मिलेगा? Check it. Give it in the formula. Therefore mass percentage of nitrogen will be equal to, mass of nitrogen is this one, so 14 into 2 into V minus V1 by 2 into molarity M divided by 1000. This is the mass of nitrogen. By mass of organic compound, consider M. M is the mass of organic compound, and multiplied by 100, because whatever come that you can write it in percentage. So given mass of nitrogen by total mass means mass of organic compound into 100, the result come, that will be the mass percentage of nitrogen. So finally from Zelder method we got this formula. Now you can simplify it. Now you can simplify it. That will be equal to how much? So this 20 cancel. After cancellation 10 remaining, and 14 to the 28, 28 by 10. So you can say that, or this you can leave. Anyway you can remember, you can simplify it or you can leave it as it is present. So if you simplify, what will be the result? If you simplify 20 cancel, 28 by 10, 2.8 into V minus V1 by 2 into molarity divided by M. This is the mass percentage of nitrogen. Now what are the terms used here? M is the mass of organic compound. What is V? V is the volume of sulfuric acid, total volume of sulfuric acid. And what is V1? V1 we have considered volume of sodium hydroxide. V1 is the volume of NaOH, sodium hydroxide or any alkali given in the question. So in this way we will use formula for finding the value of the mass percentage of nitrogen. So once again let us short revision for this. The first organic compound was given. That organic compound containing nitrogen is treated with concentrated sulfuric acid. If we treat concentrated sulfuric acid, then organic compound containing nitrogen, nitrogen will convert into ammonium sulfate. Then that ammonium sulfate is treated with alkali. Then nitrogen present in there converted to ammonia. Now we require the volume of ammonia used. For this, ammonia is base, so react it with acid, react it with concentrated sulfuric acid. So sulfuric acid, what volume it will be used, we don't know. So sulfuric acid is taken in excess quantity. Sulfuric acid is taken in excess quantity. And let the volume of sulfuric acid be V. So this will neutralize ammonia. Okay. Now he neutralize, then excess, this neutralize this. What is the left part of sulfuric acid? Is used to neutralize NaOH. Is used to neutralize NaOH. Suppose volume of NaOH is V1. So see, for 1 mole of sulfuric acid we require 2 mole of NaOH. Okay, so we require 2. So this will neutralize this. So how much? Suppose this is 2. So 2 volume of NaOH require 1 volume of sulfuric acid. Why? If you take 2, then Na2SO4 will be there, na? 2OH, 2H2 water will be there. Okay. So 2 volume required 1. So V volume required V1 by 2. So for 2, 1. So for 1, 1 by 2. V1, V1 by 2. So initially it was V. V1 by 2 is used in NaOH. What is left? Finally it is left how much? It was V, and V1 by 2 is used for neutralizing NaOH. So finally left is used to neutralize this. This will be used to neutralize ammonia. Now see, 1 volume required 2 volume of ammonia. So this volume required 2 times of ammonia. So we got volume of ammonia as this. 1 volume required 2 volume. So this volume required this volume of ammonia. So we got volume of ammonia as this. Volume of ammonia as this one. Now from volume we will convert it gram with the help of molarity. So we have told that 1000 ml or 1 liter of 1 molarity contains 17 gram ammonia, as I have shown in detail. To 17 gram ammonia or 14 gram nitrogen. So this much volume will contain. So 1000 if contain 14, so 1 contain 14 by 1000. So this contain 14 by 1000 into this. 14 by 1000 into this. And 1 molarity. So if molarity goes to this side, N. And this is the mass of nitrogen by total mass into 100. In this way you can solve. Now, if the theory part is clear, then only we can proceed for the numerical part. So, remember the formula, 14 into 2, V is the volume of sulfuric acid used, V1 is the volume of NaOH, M is the molarity, M is the organic compound mass. Okay, this is the molarity. Zelder method is not applicable in all type of nitrogen containing organic compound. Okay. Now let us check once. This method, Zelder method, is not applicable in all type of organic compound containing nitrogen. So for nitro compound, nitro means we know NO2. For azo compound, azo we know, suppose this benzene, nitrogen, benzene. This is called azobenzene. The name of this compound is azobenzene. So for nitro compound, suppose this is nitro compound, benzene having NO2, this is called nitrobenzene. This is called nitrobenzene. So for nitro compound, azo compound, nitro compound, azo compound, and we can say that pyridine. Pyridine is what? Nitrogen in the ring. Nitrogen in ring. This one. This is pyridine. So for this compound, Zelder method is not applicable. For this, Zelder method is not applicable. Why not applicable? Because nitrogen containing in this compound is not converted to ammonium sulfate. Nitrogen contained in this compound, because in the first state ammonium sulfate was formed, because nitrogen content in this compound is not converted to ammonium sulfate. Okay. So hope theory part is clear. Now let's proceed to the numerical part. So one numerical we have taken from this Gelder method. During estimation of nitrogen present in an organic compound by Gelder method, ammonia evolved from 0.5 gram of the compound. So mass of the organic compound is given 0.5 gram. In Gelder estimation of nitrogen neutralizes 10 ml of 1 molarity sulfuric acid. So this is volume and molarity of sulfuric acid is given. Find out the percentage of nitrogen in the compound. Now see, here nitrogen we have to find. So ammonia evolved is completely neutralized by sulfuric acid. Means here the use of sodium hydroxide is not there. We have taken excess sulfuric acid. Out of excess sulfuric acid, some is used in neutralizing ammonia, and the left part of the acid is used for neutralizing the left part of the acid used in the neutralization of sodium hydroxide. So here sodium hydroxide use is not there. Why? Because it is completely neutralized by ammonia. So we have obtained the formula this, where what is V1? V1 was the volume of sodium hydroxide used, and what is V? V is the volume of sulfuric acid. Now use the formula. Therefore percentage of nitrogen. What is the formula? 14 into 2 of V minus V1 by 2 into M divided by 1000 into M into 100. Now what is V? V is the volume of sulfuric acid. This is equal to 14 into 2. V volume of sulfuric acid how much? 10 minus V1 volume of NaOH. So in this question NaOH is not there. So NaOH volume is not used. Molarity, how much molarity is there? 1 by 1000 into M. What is M? M is the mass of the organic compound. What is the mass? 0.5. So 0.5. Now multiply these all, and into 100 is there. So this will give us how much percent? This will be equal to 56%. 56. You can check. This is 10. Okay. This is 100. Oh, sorry. This is 1000. 10 into 100. 1000 cancel. And this is 0 cone. So 14, 28 by 2. 28 by 0.5, that is 56. Okay. So let us proceed to the second numerical. So one more numerical we have taken. Question number 12.33, exercise 1. A sample of 0.50 gram of organic compound. So here mass of organic compound is given 0.50 gram. So this is the mass of organic compound M. Was treated according to Gelder method. Okay. ammonia evolved was absorbed in 50 ml 0.5 molarity sulfuric acid. What is V? V is the volume of sulfuric acid. V is the volume of sulfuric acid is given 50. Okay. What is M? Molarity. What is the molarity given? 0.5. Okay. So here volume of sulfuric acid is given. What is V? Volume of sulfuric acid. V is the volume of sulfuric acid is given. What is V1? V1 is the volume of sodium hydroxide. So sodium hydroxide volume is given 60 ml. So all values are given, just you put in, solve the numerical. So a sample of 0.50 gram of organic compound was treated according to Zelder method. Okay. Ammonia evolved was absorbed in 50 ml this much sulfuric acid. So ammonia reaction with sulfuric acid. So it is taken in excess. So what is left after neutralizing ammonia? So residual acid means left after neutralizing ammonia. That is treated with NaOH. So NaOH requirement is this much 60 ml of 0.5 m. So percentage of nitrogen. The percentage of nitrogen. What is the formula? That one 14 into 2 into V minus V1 by 2 into M divided by 1000 into mass of organic compound into 100. What is M? M is the mass of organic compound. Mass of organic compound. What is capital M? Molarity of sulfuric acid used. And what is capital V? Capital V is the volume of sulfuric acid. And what is V1? V1 is the volume of NaOH. Now put all the values which are given. 14 into 2. V, volume of sulfuric acid 50. V1, what is V1? NaOH. What is the volume? 60 by 2 into molarity. What is molarity? 0.5. Now divided by 1000, okay, into mass of organic compound 0.50 and into 100 means result will be in the form of percentage. Now simplify, what will be the result? So this cancelled and 60 by 2 30, 50 minus 30 20, so 20. So 0 multiplied by this 1000 cancel 2 2s are 4, 14 into 4 56. So answer is 56%. So just remember the formula. Mass percentage of nitrogen in Zelder method is 14 into 2 into V minus V1 by 2 into molarity by 1000 into mass of organic compound multiplied by 100. So this is Zelder method. Okay. So if any doubt and confusion are there, you can ask me in the comment section. Thank you.